fourths, what do we have here? It's a real number. It's irrational because it's the quotient of two numbers. It's not an integer, not a whole number, not a natural number, not an irrational number. And that leaves us to the very last one. You've been waiting for this, square root of 3. Why did I save that for last? It's a real number. And it turns out that that's all we can say for sure right now. But I'll tell you the secret. I happen to know, because I know a lot of mathematics, that it turns out it is not a rational number. This is an example of a number that's none of these, which forces it to be an irrational number. But why that is true is by no means obvious, and we should understand it.
Okay, a little addition to what he's saying about the square root. The square root of any number, if that number is not a perfect square, it is automatically irrational. If the number is a perfect square, it is automatically rational. So in other words, if I were to ask you the square root of let's say if I said the square root of 4, well, the square root of 4 is a whole number too, so therefore it's automatically rational. If I said the square root of 25, well, that's 5, so it's automatically rational. But if I ask you one where you could not figure out the square root, such as the square root of 7, it's not a perfect square, so therefore it's automatically irrational. The square root of 3 is not a perfect square, so it's automatically irrational. Once again, anytime a square root is not perfect, it's automatically irrational. Anytime the square root is perfect, it is automatically rational. Okay, example 2 from the book. Order the square root of 22, pi, which is 3.14, positive 1, and 4 1/2 from least to greatest. First thing you got to do is approximate the square root of 22. The square root of 22 is between 4 and 5. Okay, now how do we know that? All right, now we know that from the trick I taught you earlier. All right, if you're not sure how to get it quickly, to know that it's between the square root of 16 and the square root of 25, and the square root of 16 is 4, the square root of 25 is 5. That's how they came out with the 4 and 5. Then you list some numbers. You go in order 1, 2, 3, 4, and 5. Then you square each number. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Now we're talking about the square root of 22, so I put a square root around each number. Now I can easily tell where the square root of 22 falls. The square root of 22 is going to be between the square root of 16 and the square root of 25. The square root of 16 is 4. The square root of 25 is 5. Now we already know from previous lessons that now the square root of 22 is between 4 and 5. Well, halfway between 4 and 5 is 4.5. But the problem we have there is normally 4.5 would be a good approximation. We can stop right there. But if we look at our lists, we see that we have 4 1/2. 4 1/2 is also equal to 4.5. So that means we got to be a little bit more accurate with the square root of 22. And the way you become more accurate is you look at 22 and you ask yourself, is 22 closer to 16 or is it closer to 25? In this case, 22 is closer to 25. So since it's closer to 25, that tells me that my answer will be closer to 5. So it should be greater than 4.5. So my answer should be something like 4.5 or 4.6. In this case, it doesn't matter if 4.6 or 4.7. So in this case, it doesn't matter which one I pick, as long as I know is I can make the difference between 4.5 and 4.6 from the list. So as you can see from the book, after using 4 and 5 to know that the square root of 22 is between those two, they ended up using 4.5 as their first approximation. Since 22 is closer to 25 than 16, right? Then you know your answer is going to either be 4.6, 4.7, or 4.8. Now they chose 4.7. That's okay. The main thing is you can tell that 4.6 is different from 4.5. All right? Because the square root of 22, we're going to use 4.6. even though in the book they use 4.7. Okay, now, after doing that, we can now put everything in order. Why? Okay, now if we put them in order, it should be easy to tell. The square root of 22 we said was 4.6 or greater than 4.6. Pi we already know is 3.14, so that's 3.14 plus 1, which is like saying 4.14. And then, of course, 4.5 would just be 4.5. So now we can put them in order from least to greatest. So first would come 4.14. That's pi plus 1. That's right there. Next would come 4.5, which is 4.5. That's right there. And last would be 4.6, 4.7 or greater, which is the square root of 22. And that's how we put those in order from least to greatest without using a calculator. Okay, next we're going to be ordering real numbers in a real world context. Calculations and estimations in the real world may differ. It can be important to know not only which are the most accurate, but which give the greatest or the least values depending upon the context.
Ordering real numbers can take us from great heights to great distances. Let's take a look at a real-world example involving ordering real numbers. 4 people have found the distance in kilometers of the Grand Canyon using different methods. Their results are given in the table. Order the distances from greatest to least. So here are the distances that Tanya, Jose, Billy, and Jill all hiked. Now, it's really hard to compare these numbers because some are square roots, some are fractions, some are decimals. So let's go ahead and change all these numbers to decimals. Let's start with Tanya. Square root of 3, as you know, is approximately 1/75. Next, we have Jose. 1 2/3 is approximately 1.666, and this decimal keeps going. It's a non-terminating decimal, so we need to round. Now, I'm going to round to the nearest hundredths place just to be consistent with the 1/75 for comparison purposes. So this rounds to, and make sure that you use the correct symbols here. I don't want to use equals because it's an approximation. So it's approximately 1/67. All right. Now next, we have 1/6. Now, although that's already a decimal, I will rewrite it as 1/60, just because, again, for comparison purposes, we want to round all of these to the same place. And lastly, we have 3/2. And if we change this to a mixed number, 1 1/2, you can see now that that is just 1 5/10. But again, I'm going to add the 0 for comparison purposes. Now they're all rounded to the right place. Okay. Next, let's write these numbers on a number line. This will help us determine which numbers are the greatest, or this will help us determine how to organize our distances from greatest to least. Okay, here's my number line. And we'll just go in order. We'll start with square root of 3. So square root of 3, which is 1/75, is right here. Okay, great. And then next we have 1 2/3, which is about there. Great, 1 2/3. Next we have 1 6/10, which is exactly right here. Okay. And finally we have 3/2, which is also exactly right here. Now that our numbers are on the number line, it's really easy to see how to organize them from greatest to least. Okay. So our greatest number being square root of 3, and then the smallest number being 3/2. And there you have it. Have fun exploring new heights with real numbers. See you next time.
Okay, example 3. 4 people have found the distance in kilometers across a canyon using different methods. Their results are given in the table. Order the distances from greatest to least. Okay, and the distances are the square root of 28, 23 over 4, 5.5 with the 5 repeating, so 5.5 repeating, and 5.5. Okay, now what we have to do here is rewrite each value in such a way that they're all written the same. And the trick here is simply to write each number going out 2 decimal places, in other words, to the nearest hundred spot. So first, let's start with the square root of 28. Now, those of you who've been in class from day 1, you should know the trick to this already. But for those of you who don't, we're going to show you. All right, we're going to approximate the square root of 28 without the use of a calculator. So what I do first is I list numbers in order, 1, 2, 3, 4, 5, 6. I square each of those numbers. 1 squared is 1, 2 squared is 4, 2 times 2 is 4, 3 squared is 9, 3 times 3 is 9, 4 squared is 16, 4 times 4 is 16, 5 squared is 25, 5 times 5 is 25, 6 squared is 36, 6 times 6 is 36. Now I can easily see, then I'll put a square root symbol around each number. Now I can easily see where the square root of 28 falls. And the square root of 28 is going to fall between the square root of 25 and the square root of 36. Now, what is the square root of 25? That's going to be 5. The square root of 36, that's going to be 6. So I know then that the square root of 28 is between 5 and 6. Halfway between 5 and 6 is 5.5. Now, what I notice is in my table, I got a 5.5 repeating. Also got a 5.5 right here, so that's 5.5 there also. So this tells me I have to be a little bit more accurate with this particular number, with the square root of 28. Because right now I got it equaling 5.5. Well, that's the same as this, 5.5. So here I got to be a little bit more accurate. So how do I do that? I take a look at the square root of 28 and ask myself, is the square root of 28 closer to 25 or 36? In this case, it's closer to 25. So that means that this number should be smaller. So I mean, this number should be something like 5.4, 5.3, 5.2, somewhere in there. But the main thing is I know that it's going to be smaller than 5.5. So for this purpose, and because the book used 5.3, we're going to use 5.3. But notice now, 5.4 would have worked out based on this example. Okay, next we got 23 divided by 4. That's going to equal to 5.75. How do I do that? I use my old math. 4 goes into 23, 4 on the outside, 23 on the inside. Decimal place, add my zeros, and then I start dividing. All right, so here we ended up with 5.75. Here we got 5.5 repeating, so we round to the nearest hundred spot, so it ends up being 5.56. And now that makes it easier to compare all